Hello.
Hello.
Shalom.
Shalom. Namaste. What else?
Buenos dias.
Yeah. Konnichiwa.
你好，你ですか？我想睡觉。
Xin chào mọi người.
我好累。
I don't know. Yeah, you gotta say hello in Moldovan now.
Say hello. Bună dimineața.
There we go.
I wouldn't say hello.
Okay, yes, donkey shake. All right, so a function is continuous for all real numbers. The graph f prime is below. Ooh, what does that mean if it's the graph of f prime?
I have no
The derivative. The
Slope?
Yeah, that is.
graph.
These are all the slopes, right? Okay. So at this point right here, and this point right here, what does that say?
like the x, y is equal to f prime of x equals
F prime of x equals 0. That is correct.
0. So it's the critical number.
But it means that my slope is 0. That's important. Okay? Since I'm talking about the graph of the derivative, this is where my slope is equal to 0. That's important. So all this right here, all this over here on this side, what do I know about that slope?
It's increasing
Nope.
by
Where is it at on my graph?
Negative.
It's negative, right? So isn't this the graph of my derivative?
yeah, sure.
If this is the graph of the derivative, all these points down here are all, say it,
Negative.
negative, thank you. All those points are negative, so that means that all this right here are negative slopes. Does that make sense? It's kind of hard to wrap your mind around this. I'm not talking about the function no more. Okay, so at this moment right here, what is the slope of this?
Negative slope.
Negative, say 20.
Negative
20.
20.
Oh yeah.
This slope is negative 20. Because at the x value here, negative 1, the slope is negative 20. So what that is actually saying is f prime of negative 1 equals negative 20. So my slope at negative 1 is negative 20. That's what we're talking about now. We're just talking about slopes. Yes, it looks like increasing. Okay, but we're also going to be talking about little things. But it's not. It's not increasing. It's actually, it is a negative slope. So if it's a negative slope, that means it's going down, right?
Yeah.
So it's going down, but the slope right here would be like negative 10. Slope right here would be like negative 1.
So it's increasing.
No,
Why?
it's still a negative slope, isn't it?
Yeah, sure.
It's still a negative slope.
So it's not increasing?
It's not increasing. It's still negative, but what it's doing, it's at a decreasing rate. It is decreasing, so it is a negative slope, but at a decreasing rate. So the negativity is slowing down.
It's kind of like a negative, to negative being positive.
Okay, so if I say the slope here is negative 20, so I'm going to do, just contemplate this. So this is the function. Okay? This would be the function. So right here at this moment, right here, this would be my, whatever that is, negative 1. Okay? The slope of this right here would be m equals negative 20. Okay? Because my slope is negative, right? It's a steep negative. It's a negative 20, right? Rise over run. It's negative 20 over 1, isn't it? So that's what I'm looking for. So the slope there is negative 20. But now once I get over here, it's decreasing, isn't it? It's still decreasing. The slope is still negative, isn't it?
Yeah.
But it's at a decreasing rate. So it's getting to the point right here. It's the slope all of a sudden at this point goes to 0. So it is still decreasing, but at a decreasing rate.
So it's like, it's.
Yes, it's negative quadrant, so that's why it's all negative. Yeah.
So
Okay, so now think of it like this. So now if I was talking about a function like this,
It's kind of like it's decreasing less or something.
okay, but now this is a function. I'm going to do my functions in blue, okay? So what do you think about the slope of this?
It's increasing.
It's increasing. At what rate though?
20.
Okay. Think of the rate. Is it keep increasing? And what do you think about those numbers? As it keeps increasing, is the slope getting steeper and steeper? It's not a constant one. Very good. It's not constant. It's increasing, right? My graph is increasing, but at what rate? At an increasing rate, isn't it?
Positive.
It's increasing at an increasing rate.
Oh.
Now, here's another one.
Oh, okay, I get it.
That's increasing rate. Is that still positive slope?
Yeah.
It's still going up, right?
Yeah.
But now that's increasing
At a decreasing rate.
at a decreasing rate.
That makes sense. I get it.
Mister.
Yeah.
You said rise over run,
Yes.
but you said negative 20 over 1 and not negative 1.
Are you telling me that negative 20 over negative 1?
Yeah,
Is that what you're trying to say? What does two negatives make?
positive.
So what's my slope supposed to be?
Positive. Yeah, but why?
Because it's f of negative 1 is this. Rise over run. Rise over run, right? So is it rising at all? Is this rising?
I'm not talking about this one, I'm talking about the other one, like
The derivative?
This
actual,
this blue one or the red one?
the red one.
Okay, I'm gonna switch it back to red. Okay, go ahead.
Like, I don't get how it's decreasing. Like, I get it that it's negative, but like, how?
Okay, so this is a graph of the derivative, right? So the derivative always represents what? Slopes, right? Okay. So instead of saying it's a position value, that would be my function. Now we're actually just talking about derivatives and we're talking about slopes at each point. Okay? So think about this. What is the slope right here? 0, because the coordinate right here, so it's f prime of 0 equals 0. So it means the slope at 0 is 0. Okay, it's not the same as the xy coordinates. So right here, the slope f prime of 2 equals 0. So the slope at 2 is going to be 0.
Yeah.
Okay? So now down here, okay, I'm using this point right here. So f prime, so this is the derivative, at negative 1 is negative 20. Rise over run always represents the slope. Always. But we don't have a derivative. See this? This is in blue. There's a reason why it's in blue, because that goes with this one over here. Right here, rise over run is always going to be the slope, which is going to be over here with blue. This just tells me what it is at every point. So right here at negative 1.5. So f of negative 1.5, my slope would be whatever that value is there. Let's say negative 10. Okay, so it's not x comma y value. It's x comma f prime of x. So I think the confusion is you keep thinking of it as this is a regular graph, a function graph. This is a graph of the derivative. That cleared up a little bit?
Yeah.
Okay, let's actually try and look at this now, okay? Let's, I'm gonna clean up all this.
Wait, I have one more question.
Go ahead.
So, because like that one's negative and these are
Okay, now, this one over here?
yeah, okay, so that part is negative.
Yeah, all these points right here, negative, 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 negative.
But then what about over there?
Over here, guess what? This is negative, 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 negative. And right here, this slope on this side is gonna be positive. That's positive slopes at that point.
So because they're below the x-axis, those are gonna be negative?
Yeah.
And the ones above it will be positive?
Yeah. Because we're just talking about the derivative graph. Makes more sense? Okay, good. All right, so hopefully determine the critical numbers of f. Okay, so critical numbers would be when my
0.
slope is equal to 0. So let's say slope is equal to 0, slope's equal to 0 there, slope is equal to 0 there, right?
So 0 and 2.
Yeah.
Yeah.
So I have critical numbers there. So it's going to be where is it increasing? From 2 to where? Where is it decreasing? Negative infinity, 0, and 0 to, yeah. At what numbers x does have a local minimum? Okay, what was the rules for a local minimum? What was the rules for local minimum? Local minimum right here. What is the rules for local minimum?
It's going to be 2.
Okay, so
No, not 2.
let's look right here. So the derivative,
Has to be less than 0.
okay, from one side, from the left side, right? From the left side, okay, and the derivative has to be greater than 0 for the right side. Does that make sense? So my slope is negative, and then it's positive. If it changes from negative to positive, that makes it a local minimum.
Wow, right, you're going too far away.
There it is, sorry.
2. No, not 2. There's like some between 1 and like that point on the bottom.
No.
No, it's 2. No.
Okay, so it's going to be from,
Yeah, but it's not. No, it's changing. Like,
it's going to be
not
at 2, right?
from 2. At 2 is already positive.
Wait, what?
And it was positive before. Oh no.
At x equals 2. Because my slope is negative, right?
Yeah.
And it changes to positive. So change from negative to positive means it's a local minimum. It's a local maximum.
Oh, okay.
What is the rule for local maximum?
From increasing
It goes
to
from
decreasing and
positive to,
Negative.
negative.
is there any place where it goes from positive to negative?
No.
No, it doesn't.
Can you go back?
With how you're saying that with the decreasing at a decreasing rate, it's kind of like if fireworks or something were shooting in the air and then it slows down once it gets to a certain point.
Yes.
Okay.
But that would be increasing at a decreasing rate.
Yeah. But like
So,
it's
so
gonna be basically-
let's see. We have, here is decreasing at a decreasing rate.
Mhm.
Okay. This is going to be That's decreasing at a
Increasing rate.
increasing rate, so it's going steeper, isn't it? It's
Yeah.
steeper down. Okay, we have increasing at a,
Increasing rate.
and we have,
Increasing at a decreasing rate.
yep. Okay, this actually ties a lot into velocities. So we'll go into that later on, but it is a good thing to actually know. So what do we know about my slope? Okay, it's, from here, let's say here to here, it is decreasing at an increasing rate, right? And from here to here, from this point on, it's going to be
Decreasing at an increasing rate. Yeah.
decreasing.
Oh, yeah.
The slope's getting less, so it's decreasing at a decreasing rate. That has to do with the second derivative too, so.
Okay.
All right, suppose that the distance of an object from the origin at the time t is given by the function s equals f of t. So all the time we're going to refer to position function as s, or s of t. The velocity of a function is the derivative of the position over time. So my velocity is going to be ds dt. So I'm taking the derivative of s in terms of time. Okay? If velocity is greater than 0, the distance s from the origin is increasing with time and the object is moving to the right. We always think about this on the coordinate grid. If it's increasing, distance is increasing, it's going to be going positive. If it's negative, right here on this one, the distance s from the origin is decreasing with time and the object is moving left. So it'd be moving back towards the whatever position we have. Okay? If velocity is equal to 0, the object is at rest.
Easy.
So that means it's neither going forward or coming back. Velocity would be equal to 0. So another thing that's good to know, the absolute value of velocity is your speed. Absolute value of velocity is your speed. If it's a positive, you're going away from the start. If it's negative, you're coming towards the start. Does that make sense? That'd be a good thing to write down. Hello?
Hello?
Did you write it down? You have no clue what I just said, right?
Were you talking? I don't know who you're looking
Wait,
at.
what'd you
Yeah,
say?
Both of you guys
okay.
didn't write it
I
down.
didn't see.
Huh? Here, hold on.
So if it's coming towards
Absolute value of
You can take your onion.
velocity
This speed.
is the speed.
This
The
is
negative?
No, yeah.
Negative means it's coming towards the start, so it's coming back towards you, and the positive means it's going away. Okay, actually, I think I'm gonna stop here. And I want you guys to work on the homework because that's gonna give you guys
It's time.
10, 15 minutes, probably 15 minutes.
Wow.
So I want you guys actually working on this right now, please. So,
Not 4
and hopefully you're not just playing on your phone.
What about 4 times 3? So.
How does he have your number? That's just creepy.
No, because he cut out.
Why is this old guy texting like a high school student?
Because he cut out a newspaper.
Mr. Patrick had to
about
stop the
us
record of the
being
video.
because apparently To Kill a Mockingbird is